So the first thing we did is we looked at this wrapping function, which you just had to remember how that works with the unit circle. And before we got into the unit circle as with all the radians, we just looked at it as a question of perimeter. So if this was 0, pi over here would be 3.14, right? And if we go all the way around, 2 pi would be 6.28. Right? Half a pi comes out to be 1.57. And then go down here, and halfway, or 3 halves of pi, turns out to be 2.35. So if you knew the decimals, you can kind of figure out where these things land without actually knowing the unit circle. Of course, 5 pi over 6, you'll have to go back and do your time test again and maybe refresh your memory of what quadrant these angles are in. But the trick here is to look at the fact that it's a little bit less than 6 pi over 6, right? Right? 5 pi over 6 is less than 6 pi over 6, and 6 pi over 6 equals pi. So you know that this is, if this is pi right here, right, it's just a little bit less than that. So that's where it belongs. So that way we can place it in the second quadrant. If you have just -3, you can do the same thing and just say, well, we're starting at 0 and we're going this way because it's negative. And if this is 3.14, well, -3 would be, right before that. So that puts us in quadrant 3. So there's a bunch of different ways of kind of figuring out what quadrant you lie on without looking at the unit circle and radians. But so refresh and remind yourself on how that worked. Some of these things you'll look at now after we've done way more complicated work. You'll look back and think, oh, why is this so difficult back then? After you just had a whole summer off, and sometimes your brain's not working in full gear, and then so you might be pleasantly surprised on some of these things. Okay. Here we have 2 pi over 3 negative. So if you remember, pi over 3 is like 60 degrees, right? 2 of those, because it's 2 pi, so 60, 120. So it's like 120 degrees. That puts us in quadrant 3. And it's important to remember that, well, both answers are negative. So if you recall, the first thing I always mentioned is ask yourself, what's the sign of the answer before the answer? Okay? So we got that. And then here, recall that the x-coordinate is like the run, or the cosine, and the y-coordinate is like the rise, which is the sine. Okay? So this is asking, how far down does it go? It's asking for this distance right here. How far is it from here to here? That's the particular question what it's asking right here. And you had to remember unit circle and just, recall it or review it and know that it's -√3/2. If you still have your unit circle chart that you got, the color one from the beginning, that might be a good, helpful resource. But remember, you can't use this on the final, so it's just as a reference until you start, reviewing and practicing. Tangent was the same as slope. So if you keep in mind that tangent is sine over cosine, right? That's what tangent by definition is. Well, that's the same as rise over run, right? So we had all these things that are all equated back to basic algebra. So we got some new names like tangent, sine, and cosine, but really we can write it as rise, run, and then ultimately slope when we divide the two, rise over run. So this is just asking, what's the slope at 3 pi over 4? Okay, so 3 pi over 4, a quarter is like 45 degrees. So if you just go around here, this would be 1 pi over 4, 45 degrees, 2 pi over 4, and there's 3 pi over 4 right here. All right. And you remember the 45 degrees all had slopes of 1 or -1. This clearly is going down, so this has a slope of -1. So just a quick review. Again, this is not just going to fill in all the gaps that you might have. You're going back and additionally looking at your own work to, remember all this stuff. Let's see here. For the trig IDs, these are the ones that you cannot skip on the final. So you have to practice these. We did a Jamboard with a bunch of these questions, right? So this came early on. The trick is to work with one side and do a lot of basic math, really, and then turn it into the other side, okay? So one of the main things you could do is change all secants and tangents and cosecants into just sine and cosine. So write everything in terms of sine and cosine. So we have 1 plus secant, which is 1 over cosine. We got sine A on the bottom, and then we got tangent, which is rise over run, sine over cosine. And the easiness of these depends on your comfortable level with fractions. So the rule, like for 1 plus 1 over cosine, it's the same exact rule of how do you add 1 plus 1 over 3. If you know how to do this problem, it's basically identical. You can see it abstractly. So obviously we'd have to have common denominators, right? 3 is a common denominator, so I'd multiply 1 by 3 over 3, right? Same thing here. Only cosine is the common denominator, so I'd multiply this by cosine over cosine. Right? So you're using 5th grade, 6th grade math to do these problems. So if you don't overthink it, it's like, okay, as long as I'm good with fraction rules, you're fine. Okay? Same thing on the bottom, right? You could look at this problem as, you know, let's see, like 2 plus 2 over 3, right? Because we got sine, replace those with 2's, cosine once again is 3. I'd multiply top and bottom by the common denominator. 3 over 3, right? And I have 6 over 3 plus 2 over 3. Same thing here. I got over cosine, so I'd multiply top and bottom by cosine once again, just like the numerator. Okay? And then we can write, the whole purpose of this is writing it as single fractions. So these two fractions on the top, I can now combine them into one fraction, which is cosine of A plus 1 over a single denominator. Kind of like we would here, we'd say, okay, that's now 3 plus 1, 4 over the common denominator 3. So that's the same thing I'm doing here, just combining the tops here, and the bottom stays the same denominator. All right. And likewise, same thing on the bottom, gets a little long. Got just write everything out. Cosine of A and sine of A plus sine of A. All this so we can have it written over cosine of A. All right. Now we have the same denominator here, so you could multiply by the reciprocal of the bottom fraction, and you can see the cosine of A would end up on the top since it's the reciprocal, and these cosines would cancel out. So it's nice if you have the same denominator on these complex fractions because they'll just cancel out. So now we just have the numerators left over. Cosine of A plus 1 all over. Let's see here. Well, we have, let's do the factoring. So we have a common factor here. Right? You can see that there's a sign in both of these. So I'm going to factor that out. Let's take the sign out. So pull that out. And what's left is the sign. And then since there's nothing left here, if we take out a sign, we have to put a 1. So cosine of A plus 1. Right? As long as this distributes back to the step above. So sine times cosine is cosine sine. Sine times 1 is sine. We're okay. And now as we have it, we got the same factor on the top and bottom, cosine A plus 1. So those cancel, equal 1. So we have 1 over sine of A, which equals our goal, which is cosecant. Right, so we worked on one side until it all simplified to the other side. All with basic fraction rules. You just have to be neat. You have to write your work, you know, and practice, of course. And these do get easier. Okay? Let's see here. Secondly, okay, let's do one more like this. So same method. Take everything that's not sine and cosine and on this side and switch it around. So cotangent and tangent. We can write those as, let's see here, that'd be cosine x over sine of x plus sine of x over cosine of x. Those are reciprocals. All right, times sine of x. More denominator time. All right, same rules as if I was going to add like 4 over 3 plus 3 over 4. All right, I'd have to add Take this denominator, multiply it by top and bottom here. Take this denominator, multiply it by top and bottom here. Right? So they'd both be over 12. So that's what I'll do here. This first fraction I'm going to multiply by cosine x over cosine x. The other one by sine of x over sine of x. So we have cosine times cosine, which is cosine squared. Sine times sine, which is sine squared. All over the same denominator, cosine x, sine x. Don't forget, we still have this sine of x sitting on the outside, minding its own business. Now, as luck would have it, cosine squared plus sine squared equals 1. How nice. That was one of those trig identities. You will have a sheet on the final that you can use that had all those properties and stuff that you had during quizzes and tests. So you have one sheet that has all that stuff on there. This would be included, that cosine squared plus sine squared equals 1. Okay. Sine of x. And lastly, we can just say, well, sine of x cancels with sine of x. So it's 1 over cosine of x, which equals secant. Okay. So definitely practice those. Open up your notes, open up everything you've done before, and there's more on the practice sheet that's page 2 to this assignment. Okay. Few equations that you get to solve. Now it's the same idea as these. You don't really want to do multiplying and dividing on both sides, but you can move everything to one side. It makes life a lot easier. If you had your trig paper, you had sine of 2x, you could see that that's equal to 2 times sine of x cosine of x. And there is only one ID for sine 2 of x. There's 3 identities for cosine of 2x, but only one. I'm also going to get this equal to 0, so I'm going to subtract 3 sine x on both sides. All right. Now the reason for that is if you just kind of go back to what we did here, remember how we had a common term, sine of a, sine of a? Well, same thing happens here. Right? We have a sine of x and sine of x. So let's factor it out. Take out the sine of x. What's left over? You got a 2. A cosine. The second term would just be the minus 3. And you can just use the 0 property like we've had before. So we break this up like kind of like after you do the box or the x. So when does the rise or the sine of x equals 0 on a unit circle, and then this whole thing. When does that equal 0? Okay. So anybody remember what angles are have a rise of 0 on a unit circle? Which one have a rise of 0? 0 that way, pi that way. So there's your two answers, 0 and pi. What about this other one? If you get it equal to 0, you'll see it's cosine of x equals 3. So cosine of x equals 3 over 2. Now, where is the run? These runs equal 1, right? 1 and negative 1. Where is the run equal to 1.5? Nowhere, right? So this would be a no solution. If you put this in a calculator and you typed in, well, what's the arc cosine of negative 3 over 2? It would have said domain error, right? So that's the way you get a no solution for that. So that means your only two answers are 0 and pi. So those require factoring. It's a little bit more, involved. These ones are a little more straightforward, but you have to know your unit circle to solve them. So it's kind of like the last step we did just a second ago right here. We had a minus 3. I added 3. It is a 2 cosine, so I divided both sides by 2. Same thing here. Subtract the root 3. And divide both sides by 2. So you had to remember, where is cosine negative? So we always look at the signs first. So what quadrants is cosine negative? So I'll go back to here. Remember, we're talking about the run. Where would the run be negative, or the x be negative? Okay. Yeah, that'd be here and here. All right, so you have to figure out which of them have a run of negative 3 pi over 2, negative root 3 over 2. And after a little bit of remembering, you come up with 5 pi over 6, which is right here. And then its complement, which is down here, which would be 7 pi over 6. Because in the middle would be 6 pi over 6. 6 over 6 would just be 1, or 1 pi. Okay? So those would be your two answers there. But you always had to ask yourself, what quadrant are you in first, and then answer the question, right? Because you usually get two answers, and you have to know what quadrants those belong in to get the right angles. Okay, almost done. Just a little review on graphing. We did a whole separate quiz just on this. Okay. So we have amplitude of 3. Okay. Period was just going to be 2 pi divided by this number, 2. So we get a period of 2, which means it repeats every pi instead of every 2 pi. So it's going to compress together. A phase shift. So we have, it'd be pi over this, which is 2. So our graph is actually going to start at pi over 2, not at 0. So cycles and period are kind of similar. They look at the same thing two different ways, so it was easier to pick one or the other and not try to handle both at the same time. So we're going to start at 3, but move over pi over 2. Okay, so that would be right here. And it's going to repeat itself every pi. So that means by the time I get over here, it's going to be back to the beginning. So the way we did this, we plotted the beginning, the end, and then found the middle of that. So I know it's going to drop down to negative 3 here. And then the middle of these two is where it's going to cross the axes. Right? And as soon as you get one of them, you could just tessellate it and keep repeating it. And drop it down the other way. And there we go. So a little quick review. Again, look at your own stuff and complete the homework that's attached to it, and bring it back on Friday, and we'll do part 2.